All right, so here are your examples for section 4.7, part 2. So number 33. So you got a piece of wire, 10 meters long, cut into two pieces. One piece is bent into a square, and the other is bent into an equilateral triangle. So let's draw our square and equilateral triangle. And we started with 10 meters of wire. 10 meters of wire. And how should the wire be cut so that the total area enclosed is A, a maximum, B, a minimum? So in other words, we're going to take that wire, allocate some wire to become a square when you bend it, and some wire to become an equilateral triangle. So the variable we need to keep track of here is how much wire we take to make the square, and then 10 minus that would be the amount we take to make the equilateral triangle. So let's let x equal the wire in the square, amount of wire in the square, and then 10 minus x is the wire in the triangle. So if we do some calculations here, we see that then each side of the square would have a length of x over 4 because we have total length x for the wire in the square, 4 equal sides, and in the equilateral triangle, 10 minus x over 3. So now we need some formulas for the areas of these two objects because we're going to try to maximize or minimize the area. So we need to find a formula for the area of a square. Well, that's pretty easy. It's just that number squared. So the area of the square is x squared over 16. Plus, we need a formula for the area of an equilateral triangle. I'm going to assume that you looked that up online, which is legal since this is homework. It turns out to be root 3 over 4 times the side length squared, which is 10 minus x over 3 squared. And that's the thing we're trying to maximize or minimize. So that formula is a good one to find the derivative of, set equal to 0, solve for x, all that stuff. So find the derivative. A prime is going to be equal to 2x over 16, which is x over 8, plus root 3 over 4 times 2 times 10 minus x over 3 times the derivative of the inner function, which is minus 1 over 3. All right, now we got to simplify that a little bit. And we're setting that equal to 0. So we got x over 8 plus, let's see, so that's 3 times 3, that's 9. Times 2 over 4, that's 1 half. 3 times 3 times 2 is 18. So it's root 3 over 18 times 10 minus x. Let's put that minus sign right over here. Let me just check that I got everything. So x over 8 stayed the same. Root 3 over 4, but then multiply by 2 in the numerator, so that's times 2 in the denominator, times 3, that's 6, and 3 is 18, 10 minus x minus 1, ends up over there. All right, so now we can set that up as x over 8 equals root 3 times 10 minus x over 18. And now we can cross multiply. So we get 18x equals root 3 times 8 times 10 minus x. Let's see, we can cancel out a factor there. We can cancel out a factor of 2 in the top and on both sides. So we get 9x equals 4 root 3 times 10 minus x. All right, so we got to solve for x. Oops, it's going off the board. Let's see if I can get that. There we go. So now let's just keep on going. I think we have a tiny bit of room here. So distributive law on the right, 9x equals 40 root 3 minus 4 root 3x. And so we get 9 plus 4 root 3x, if you add 4 root 3x to both sides, equals 40 root 3. And divide by that, we get 40 root 3 over 9 plus 4 root 3. All right, so we only get one number. We're supposed to find where the area is a maximum and where the area is a minimum. So that's kind of suspicious. We only have one critical value for two things. So now you got to look at the graph of the area as a function of x. So here's x, here's the area. And I think what you get is a graph that looks something like this. You got a special value right over here. That's your minimum, which is that x equals this crazy number, 40 root 3 over 9 plus 4 root 3. And then there's no maximum, except you got to keep in mind that there's a limitation on x. The biggest x can be is 10. So actually there is a maximum that happens when x equals 10. X equals 10 is going to give you the maximum. So let me just move over to the other side of the board. So conclusion, minimum when x equals 40 times the square root of 3 over 9 plus 4 root 3. Max when x equals 10. All right, let's interpret that answer. We interpret that answer. So the minimum value, in other words, the smallest possible area, is when you take x to be this amount and you allocate this much wire to the square and 10 minus that to the triangle. The maximum area is actually when you take x to be 10, which means that all of the wire is used for the square and none for the equilateral triangle. So the best way of maximizing your area is just to not even bother making a triangle at all and just make a square. So that's what that's saying. All right, and number 66. Number 66. Oops, that cannot be seen. So now I got this nice diagram here. A steel pipe is being carried down a hallway 9 feet wide. At the end of the hall, there is a right-angled turn into a narrower hallway 6 feet wide. What is the length of the longest pipe that can be carried horizontally around the corner? So this one is tricky to set up and to make sense of what you are being asked to do. So label something over here. 9 is this length. This length is 6. And here we have our ladder that we're carrying horizontally. We're trying to get it around that corner. So they give us an angle over here. Sort of strange they give us the angle. That's not really what we're after, is it? We're after the length of the thing. So this problem's tough to get oriented because it looks like it's a maximum problem. It's actually a minimum problem, and let me explain why. What we're really after is where is the ladder going to be constricted the most? In other words, at what point in its traverse from going here, like here you could have the ladder be as long as you want, but as you turn it, there comes a certain point where it's like constricted if it's too long, and then as you keep moving, it's going to become constricted even more and more and more, and then finally like sort of get through the bend, and you're sort of home free. But there's a certain point where the ladder is like constricted the most, and that value then tells you the biggest possible ladder you can fit through here. So it's actually, you want to minimize this length over here. So you actually want to minimize, very tricky, minimize the length L as the angle theta varies. So what we need to do is figure out an expression for the length of this. So maybe it helps to draw a few other ladders. See how this is much longer if the angle is bigger, and probably also much longer if the angle is smaller. The angle is smaller. There's some sort of angle where the length of this line is as small as possible. All right, so now how on earth are we going to do that? Let me erase this so you can see the original picture again. Let me just do it over again. Draw it again. See the whole thing. That's 9. That's 6. Excuse me for not drawing that to scale. Here's your angle. You want to find that length in terms of theta. So maybe you recognize, looks like you can maybe set it up as two right triangles. Actually, I'm surprised that they give you this angle. I would have rather dealt with this angle. Oh, maybe I can do it like this. I'll make the triangles the other way. Make it vertical. That way you get. So the length is given by, let's call this L1 and L2. The length is equal to L1 plus L2. The length of this first bit plus the length of the second bit. That's the angle theta. That's also the angle theta. They're equal angles over there. So now we can use some good old SOHCAHTOA to figure out a formula for L1 in terms of some numbers we know. We know this is 9 and we know this is 6. So there's your geometry trick. Now we got something like a good setup here. So L1, so let's think of what's the relation between these numbers. Looks like a sine theta equals 9 over L1. Sine of theta equals 9 over L1. And cosine of theta equals 6 over L2. Yeah. So now we need to find an expression for this. So we need to solve for L1 and for L2 in here. So L1 is equal to 9, just flip the numerator and denominator here, 9 over sine theta, and L2 is equal to 6 over cosine theta. I believe that works. Now you have a setup because you know L1 and L2 in terms of your angle. So now we can plug everything into this formula. So let me go over to this side. So L is equal to 9 over sine theta plus 6 over cos theta. And that's the thing you want to find the derivative of and set equal to 0 and all that good stuff. This looks a little bit tricky. You might end up having to do it on the calculator. I'm not sure we can get an exact answer. Let's take a look and see. So anyway, we do the derivative. So we get L prime equals, we got to use the quotient rule a couple of times here. Or remember that this is secant and this is cosecant, and use the rules for the derivatives of those. But I'm just going to do this with the quotient rule. So it's going to be 0 times sine theta minus 9 times cos theta over sine squared theta. And over here, we're going to get derivative of 6 is 0. 0 times cosine plus 6 times the derivative of cosine, which is minus sine. So we get minus 6 sine theta over cos squared theta. We want to set that equal to 0. So now, bring that over to the other side. We get 9 cos theta over sine squared theta equals 6 sine theta over cos squared theta. Cross multiply. So we get 9 cos cubed theta equals 6 sine cubed theta. All right, now let's divide by 6. So we get 3 over 2 cos cubed theta equals sine cubed theta. And so we get 3 halves equals sine cubed over cosine cubed, which is tan cubed theta. Okay, that you definitely need a calculator to figure out. You want to find tan theta equals the cube root of 3 over 2. Or in other words, theta is the inverse tangent, arctan. I don't know if in pre-calc you use arctan or inverse tan. Let's write arctan. The cube root of 3 over 2. What a crazy number. So we want to minimize the length as that varies. So you're going to get a horrible expression here for the minimal length. Let me just erase this. It's actually possible to simplify this, but I'm going to leave that not required because that requires you to know some stuff about drawing right triangles, things like that, which I think only Bennett had to do for the AP Honors. So you're off the hook. Length is equal to L1 plus L2, and L1 was 9 over sine theta, and L2 was 6 over cos theta. So the actual L, so probably what you're going to do is actually find a number for this, right? That's what I hope you do. Actually find the angle in degrees, and use a calculator and stuff like that. But I'll just write the unsimplified version here. It is possible to algebraically simplify this. 9 over sine of arctan of cube root of 3 over 2 plus 6 over cosine of arctan of cube root of 3 over 2. Again, use a calculator to simplify this. I just don't want to get my calculator out. Well, maybe I'll just leave it at that. All right, so there's your final answer in a horrible looking form. Again, on your homework, I expect you to actually simplify this, so please do. Don't just leave that answer copied down. You should be able to plug that into the calculator.